Okay, so two-way ANOVA. And everything we're going to do is two-way ANOVA with replication. Okay. Now you may have noticed when we did a minute ago when we did one-way ANOVA or single-factor ANOVA in data analysis, it asked for, or right underneath that it said two-way with and two-way without replication. As soon as I show you what that means in a second, you'll be like, "That's the stupidest thing I've ever heard of," if you say without replication. So we'll never do that. It's always with replication. So it'd be the idea of, I know for the science fair I'm going to grow plants, yes, in sandy soil versus, I don't know, a nice silt soil. Good for us. And then this way, and oh, maybe a loam too. Oh, weird. Loam. And then this way I'm going to have fertilizer with no fertilizer. And I'm going to grow literally one plant in each one. At this point, you're getting pissed off because who would grow one plant? Exactly right. This is stressing me out. Art's supposed to make you peaceful. It doesn't. Okay. Without replication would be there would be only one plant per each cell, which is ludicrous. Okay? So we're going to have multiple plants in each box. So multiple plants in each cell. That's what it means with replication. Okay? So I don't know how many there are. Maybe there's 10 here, 10 here, 10 here, 9, 8, 10, whatever. But in the case of Excel can only do a balanced two-way ANOVA, which means there has to be the same amount in each one. It's a very tricky process to set up a program from a computer standpoint to understand how to do it when it's an unbalanced one. So Excel can only do a balanced two-way ANOVA. Okay? And so what will end up happening is this. So, and again, you have to pick something to measure. So I guess if they're plants, I suppose heights. Heights, I suppose, could be measured here. And so that's all you're measuring. You're just comparing their heights. Now, what could be changing their heights? Fertilizer or soil type could either one be affecting their heights. So there's actually going to be 3 hypotheses. There is no difference in height. Due to soil type. And of course there is, or at least one is different. And then H naught, there's no difference in height. Due to fertilizer. And then of course at least one is significantly different. And then the last one is always there is no interaction between soil type and fertilizer. And of course, the opposite of that is there is interaction. That one looks a little different because there either is or there isn't interaction. Okay? So, in this situation, I suppose if you're growing tulips, they might not like sandy soil, but they might be happy with either of the other two. It's possible. It's possible that when you fertilize them with sandy soil, they do better than when you whatever. It could be a variety of different things. But that's what we're going to be checking on here in a minute. And again, we chose height, but it could be anything that you're measuring. How many tomatoes they put on, whatever it happens to be. There will always be those 3 hypotheses. And the way the book writes it is there's no difference, and they'll say due to column factor, and there's no difference due to row factor. Okay? Because they're on the rows or they're on the columns, and then there's no interaction between the columns and the rows. Okay, that's in general, that's how you write that. Now, notice how, whoops, kind of scared me. Sorry. Now, notice how there is only just the 2 for fertilizer, no fertilizer. Well, that's cool, because what would happen in a minute is this. What if there was no difference due to sandy soil or anything? Well, then it would just be a matter of between fertilizer and no fertilizer. Well, that would just look like a giant t-test, yes? Or a z-test, because if you turn these on their sides, it would just be you have a column of fertilizer versus a column with no fertilizer, okay? It's possible that fertilizer doesn't make a difference, I suppose. So if it doesn't make a difference, then it would just be all about soil types. I have to say, when I was a kid, growing up farming, every year Washington State, Oregon State does it too, but every year Washington State comes out with this thing where they've gone and run test plots all over the east side of the state over there. And here are all these different types of wheat, different varieties of wheat, and they'll grow them in different locations, different elevations, different rainfall amounts, different whatevers, and they use different fertilizers. They do all these different tests. And so where we were in about a 19-inch a year rainfall, this particular crop, this wheat variety or this wheat variety were really good where we were. Other ones were really good other places, but not so good where we were because they needed more rain or less rain or whatever. Some needed more, snow covering in the wintertime than we had or whatever. So it really boils down to what fits best for where you're at. Can you not read my handwriting? It's pretty bad.
That interaction?
There's no interaction. No interaction. Yep. Well, wait a minute. If there's 3 hypotheses, there better be 3 p-values. And you're right, there will be 3 p-values. Nice. And so our table will look like this time. So for a 2-way table, oopsie daisy, what just happened? Uh-oh. Apparently I zoomed. Sorry about that. For our ANOVA table this time, it'll look like this. And I'm not sure which is which in Excel. It's been a couple of days since I did it. It's not important. There'll be sum of squares. There'll be sum of squares for the row, sum of squares for the column, sum of squares for the interaction, and sum of squares for error. That'll be a degrees of freedom. This will be row minus 1. This will be column minus 1. Interaction's weird. I can't remember off the top of my head. It's not important. We'll get to those in a minute. Mean squares is sum of squares for the row divided by r minus 1. Sum of squares for the column divided by c minus 1. Sum of squares for the interaction divided by its degrees of freedom, which I'll do in a minute. So I have to look it up because I forgot. And then here's where it gets important. There's going to be 3 f's. So it's going to be mean squares for row divided, oops. Sorry about that. It's going to be mean squares for row divided by mean squares error. Mean square column divided by mean square error. Mean square interaction divided by mean square error. And then here's the deal, 3 p-values. 1, 2, 3 p-values. Okay? Again, I'll finish filling the rest of that in. But this is where it's at. You come over and look at these 3 p-values right off the bat. Boom. If they're less than 0.05, then there is a row factor. In this case, fertilizer is important. If this one is less than 0.05, then soil type is important. If this one's 0.05 or is less than 0.05, then there is interaction because some fertilizers and some soil types work different together. Okay? I'll finish filling those in. I want to say it's row minus 1 times column minus 1, but as soon as I write that, I'll be wrong. Come on, is it? I feel like it is. I feel like just writing that down. What's the worst that could happen? I mean, you'd be wrong, but besides that, what's the worst that can happen? We'll leave those alone for a second. We'll run the test first, then we'll come back to that. Because after we see it, then we'll be like, oh, yeah, that's right. Okay. So there's that. We'll leave that alone for a second. I really want to say this is... If I do that, it'll make myself mad. So we'll leave those alone. We'll fill them back in a minute. So if you come back over to Excel, I'm just going to make up some data here. So it's going to look like this every time. This is how it has to be inputted. And this is kind of a tricky deal, because if you don't do this right, the whole thing goes to heck in a handbasket on you. Okay? So what did I say the first one was? Sandy, silt, and loam or something. And then fertilizer, no fertilizer. Oops, not there. God dang it. Okay, can you see what we're doing here? So we're saying in sandy soil, we got these three that are getting fertilizer, these three that are not getting fertilizer, yes? So I'm going to do the same thing with silt. Okay? That's how they always have to be put in. It's kind of a big deal. Okay? And if there was another set, like if you had fertilizer A, fertilizer B, and then fertilizer C would go right here, then you add three more down from there. Okay? In other words, we're taking 3 rows. 3 rows go with each one of these rows over here, yes? So in other words, 3 lines go with that. That's kind of a big deal. Just looking at the data, what do you notice? Fertilizer does better than not fertilizer. Big, I'm shocked by this, yes? I'm just absolutely 100% shocked by this. The question is it significantly different? We're going to figure that out in a minute, okay? Looks like loam is better than silt maybe, but clearly better than sandy looks like. Just eyeballing it across there. But notice that as you move across, it moves the same direction. This starts a little lower, it works medium, it works higher. Same thing is true down here, yes? This leads me to think there's no interaction. Because if there was interaction, what I would see is this might move up on the top row, but it might start high and work low on the bottom row. That would indicate an interaction piece, right? Because they both move the same basic direction, probably no interaction here. Okay, we'll do one later with interaction, but I don't think this one's going to have interaction. So, let's go to data, data analysis, 2 factors with replication. So input range, it's everybody, all the way up there to the top. Now, how many rows per sample are there?
3.
There's 3 rows per sample. And then our output range, I'm going to stick down here, down here somewhere. Oh, shoot. Gosh darn it. I screwed up my input. There we go. I hit OK. What's missing now? Oh, I didn't put an output range. God dang it. All right, there we go. Nice. Oh. Okay, sweet. So there it is. So down here we have a lot of extra information that you're like, wow, it's a lot of information.
What did you put in for the output range?
Just pick a, I think I clicked on A11 or something. Just somewhere down here, A9 or somewhere down there. It's not really important, just somewhere not on top of my data. Okay? And so what I have here is for fertilizers, now I'm comparing the average for silt versus loam versus, where's sandy? Oh, there's sandy right there, yes? Okay? And then for no fertilizer, that's down here below, yes? There's sandy, silt, and loam, right? Okay. So here's the overall average for no fertilizer. here's the overall average for fertilizer. So when we do this thing, or in other words, when this thing is going on behind the scenes, it's testing to know, okay, hold everything else constant, let's just compare fertilizer versus no fertilizer. That's what we're testing down here in a minute when you see that down here on the row. And in a minute down here, we get down here, we're talking column, we're saying hold everything else constant, just compare side to side. Hey, let's compare silt versus loam, and silt versus sandy. So down here in the table, this is what we came to look at. This is what we're here to be excited about, those three numbers. Okay? So our p-values. Holy cow. Now, if you're not sure which is which, obviously columns is, well, it's columns. And so samples is the rows. That's how Excel denotes it. I personally come in here and alter this so it makes more sense to me. So fertilizer, and this one was soil type. Oops. So it makes more sense. So, is fertilizer important? Yeah, duh. Is soil type important? Wow, yes. Very important. 0.0003, that's huge. Is there any interaction? No. It's greater than 0.05. Okay? So, back to our data over here. Here's the deal. Bottom line is, we're going to reject H naught. You know, fertilizer makes a significant difference in, I guess, heights is what they were. Reject H naught. Soil type makes a significant difference in height. Okay, and then fail to reject. There's no interaction. When I was a kid, there was a place not too far from where I live where they get like 12 inches of rainfall a year, that's all. And that's on an average year. So if they went out and fertilized heavily, they were just throwing money away, okay? Because they didn't get the rain to grow the wheat. But there were some years when they got a bunch of rain and they would get, instead of getting like a 30 bushel crop like they usually did, they'd get a 60 bushel crop, which was terrible for us, but you just freaking double your yield. Are you kidding me right now? Wow, that's a big deal. For us, it would go from like, oh wow, our average was 75, 80. On a good year, you pull in 100, okay? Which is pretty good, but that's only a third better. It's not 100% better, for God's sakes, okay? And so there was only so many things these people can do. So you're like, well, I know, I'll just put more fertilizer to it. If you don't have the rain, you're just wasting money, okay? And it was dry land farming, so it wasn't like you could just go irrigate it more, okay? It just didn't work that way. And so these are the things that you're like, wow, well, it's, you know, in other words, does fertilizer matter? Yes. Does the amount of fertilizer matter? To a point, to a point. Now, if you had plenty of water, then yeah, it matters all the time. Just keep pounding the fertilizer to it and pounding the water to it pretty much forever, sure, until you run out of money, okay? Yes. But out in the dry land, well, to a point it matters, and then at some point you just run out of water. If you don't have water, you're wasting your time, okay? And so there's that idea of interaction piece, where you're located, or the rainfall and the fertilizer, there's a significant interaction between those two. Okay, now, back to our values here. I'm going to go find out this thing because it's kind of irritating me. All right, so back over here. Look at our degrees of freedom. By God, I should have done it. This is row minus 1 times column minus 1. This is just bugging me, so I'm going to put it back here. Row minus 1 times column minus 1. Right? And then the last one for error. The last one for error is there is 12 degrees of freedom. 12 degrees of freedom. Where does that come from? Let me think. 1, 2, 3. It's 18 there, yes. 18. And is it n minus, yeah, it's n minus RC, and RC minus 1. Ah, That's going to drive me nuts. I'll leave it blank for a minute. And this last one is just n minus 1, of course. The total is big N minus 1. That's going to bug me. God, that's going to bug me. No, I'll think of it later. I'll look it up later. It's not really that important. It's not really that important. Although, you know that all this stuff here has to add up to n minus 1. So if you foiled this out, foil it out, and then you could take this guy here, subtract all of that mess to find that guy right there. I'll do that later. That's going to bother me. No, I'm going to do it now because it's really bothering me. There was a time when I wasn't so anal about things. That's RC minus R minus C plus 1 plus, I'll just call it X for right now. Cool. Hey, look, there's a negative R and a positive R. Cool. There's a negative C and a positive C. Cool. There's a negative 1 and a positive 1. Awesome. So then N minus 1 minus another 1 minus RC is X. Yeah, that's technically right. That's technically right, but that's not how they write it usually. Never mind. Not important. I will add that to the video this week when we get to it. If you look on sheet 3, I have some more data for you. I think this is a medicine thing and a time thing, as I recall. I don't remember having the story in front of me. But notice, when you first look at the data, look at it, I like to look at the columns first. If you come down the columns, right, this upper piece tends to be bigger than the lower piece here, yes? Is that true here as well? Yes. Is that true here? Maybe-ish, yes? It's kind of weird, because that's not so obvious this time. Going from left to right, this one, this one, this one. It seems like it's growing going across the bottom. It seems like it's pretty much growing going across the top too. That kind of says there's probably not a lot of interaction here. In other words, it's all going the same direction both ways. Okay? I would argue this last one is pretty big and small at the same time. This one here is I bet there's almost no difference between these two in a minute. We'll probably figure this out. In other words, it's quite possible that there is column factor, but probably mostly because of this guy here only, yes? This one's the only one that really seems significantly different than those two. And top versus bottom, I'm not sure there's a great deal of difference top versus bottom, but it looks like the top's probably a skosh smaller than the bottom, but not a lot. So when we do this here in a minute, don't be surprised that there's barely a row factor, there's barely a column factor, and I don't think there's going to be any interaction here at all. So if you do data analysis, highlight your data, and this time there's 1, 2, 3, 4 rows per sample. And I'll make that like 12 this time or something. Look at that. Look at that. Yeah, baby. Okay? So again, the rows are significant, 0.001. The columns are also significant, 0.0003. That's huge. And again, there is no interaction between the rows and the columns. Again, not really sure what they are. Wish I'd had a story to go with it, but apparently I lost my stories that went with my data, but whatever, that goes on. Okay? So it could be something about is it the 10-hour, like you're taking them at 2-hour intervals, 3-hour intervals, or whatever, and then there's this mega doses of NyQuil or whatever it is, and then however it affects your sneezes or whatever. I don't know. I don't have that in front of me right now. It's not that big a deal. So when we do that, just be aware of that going in. Wait a minute. How many rows and columns are there? There's 3 and 2, right? 3 and 2 is 6. 24 minus 6 is 8. No, that's not right either. No, it's not important. I don't care. Okay? We'll get to it. So again, you would reject H naught. There is a difference due to rows. Reject H naught. There is a difference due to columns. Fail to reject. There is no interaction between the rows and the columns here. Yeah? Nope. Nope. Where's my other one? There it is. Oh. Hey, that's the same one. Weird. Weird. Now, what if, hypothetically, what if I change some of these up a little bit? Okay. I'm going to change the top one just go to. Interestingly enough, this time, I don't think there's a great deal of difference in the average of the columns. If you look at these columns here, granted, these ones are all pretty much right in the middle. These ones, there's a few higher, some lower. This one might be significantly different average-wise, but this one had really low and really high. I'm not sure there's a great deal of difference in the column averages this time. Okay? I'm not sure there's a great deal of difference in the row averages, although it looks like the 10 one might be significantly lower average than the top one, yes? Maybe because of this bunch right here, and because that's so much higher, this one might be significantly lower than is the 8-hour one, okay? But what I notice is this. On the top row, moving from left to right, the numbers are getting bigger. On the bottom rows down here, moving from left to right, the numbers are getting smaller. That is a dead giveaway that we have interaction going on. Dead, 100% giveaway that there's interaction happening here. Okay? On the last two examples, as you move left to right across the page, everything was moving the same direction, either going higher or going lower. Here, they're going opposites. On the top, they're going up, on the bottom, they're going down. That is a dead giveaway that there's interaction happening. Okay? So, when you look at the data here, just be aware of that going into this thing. Boom. Yes, sirree, Bob. Look at that. So our p-value for the rows is huge, which is kind of what I thought might happen, right? I said that I thought that top row might be significantly bigger than the bottom row. Yes, I thought that might be true. But the columns, there is absolutely no difference in the columns. Okay? No significant difference. But the interaction is huge. Okay? When this happens, if this happens, you must not throw out the columns. For God's sakes, I know they're not significant by themselves. But when you mix them with the other thing, you can have problems. Okay? This is why when the pharmacist says, hey, what other drugs are you on? I'm not going to tell him about this one. And you don't wake up tomorrow, you have a problem. Okay? You must tell them this is a bad thing. You do not want them to do this. Okay? You don't want to die. So, yes, there is no significant difference due to column by itself. But the fact that there's an interaction, you have to keep it in the model. You have to keep it in there because it's a significant part because of the interaction. Okay? Now, if there was an interaction, if there was no interaction at all, and watch me get rid of the interaction piece. Watch me make up some data that would tend to get rid of interaction. Whatever. Oh, no, shoot. Cool. Cool. Oh, look at that. Oh my word. This time, is there any interaction? No. No. The computer's going, screw you, there is no interaction. 0, 100%. I've never seen it actually that big, a p-value, but there it is. Good for us. There's no interaction. Throw it out. Okay? Notice how I almost got rid of all of the row factor, yes? 0.047. In fact, I'm going to do that in a second. But in this case, yes, I'm going to reject H naught. There's a difference due to rows. There's a difference due to columns, but there's zero interaction here. Okay? Again, no interaction because moving from right to left, top and bottom, everything's going upwards on this deal. All right, let's see. What could I do to make that go away? So 8 hour is 25. I need to bump my 8 hours up a skosh. Here, bump him up to 25. Bump him up to 26. Bump him up to 27. Cool. I bet it works now. Now I want to illustrate something here. Because these are all what ifs. Obviously you're not going to be screwing with your data, changing your data. Just saying, what if this happened? Okay? Well, looky there. Look at what's not important anymore. The rows are 100% not important anymore. Columns are still huge, right? So the dosage matters a lot here, in other words, whether it's 100 milliliters, 200 milliliters, or whatever, okay? But there's no interaction. Now, wait a minute. If the rows are not important, and there's no interaction, only the column is important, what does that mean then? What does this mean? It means that I no longer need this garbage right here. Are you with me? I no longer need to deal with that. All I need to worry about now is this stuff. And so if I copied this and I just paste it into a new work page somewhere, what does that look like to you? What does it look like? Is that? Is it one-way ANOVA? Exactly. Exactly right. Because what's the problem with two-way ANOVAs? The problem with two-way ANOVAs is you cannot take it really a next step further and go, which is the best one, really? Or how is this one different from that one? Very easily, because there's no like Bonferroni test for that. But since the rows were not important, and since there was no interaction, then get rid of the rows, forget about it. Nobody cares anymore. And look at just the columns. And then you can compare the columns in a one-way fashion. Interestingly enough, if you did that, look what happens. I do find this interesting. I hope you do too. No. There we go. Yes, yes, yes. Cool. Okay. There we go. Oops, where are they going? Back to here. Yes. No. Here. Nope, that wasn't it. Never mind. So there it is. So here's the deal. Bottom line. Now, obviously, look at that. Between groups, again, just like before, the different dosage levels is hugely and critically important. And then now it's a matter of checking our Bonferroni to see which one is the best. And again, here is our averages right there. This is fairly small. I would be shocked if they weren't all significantly different. I'd be fairly shocked by that. So again, if it's me, I probably make my denominator first. And it's the square root of MSE times, and then it's 1/8, oops, plus 1/8. Boom. There's my denominator, and then just equals him, oops, him minus him, equals equals there they are. Okay, And if you do equals T dot inverse, okay, T dot inverse, and then it's 0.025, comma, and then our 21 degrees of freedom here, because that's for our error. And what you can see is this. There is no significant difference between 1 and 2, yes? Between 1 and 2, there's no significant difference, but there is between 1 and 3 and 2 and 3. So if it were me, I would say 1, there's a significant difference between 1 and 2. So what I would have done is this. Initially, on the two-way, there was no interaction and no column factor. So do one way, okay, and there is a significant difference between 1 and 2, okay? Something along those lines. That's disturbing. Well, that's not helpful. Wrap text. Oh my God, you're an idiot. Okay. I tried to make it better. I think I made it worse. There. That was my thought process when we did that. I hate you. Okay. Can the man run Excel? No, apparently he cannot. I hate your guts, you stupid computer. All right, whatever. I don't care. Something along those lines. Okay? That's the thought process there. So if and only if you only have one, either column or row, and no interaction at all, you must drop back to a one-way ANOVA. Okay? It's that idea that, well, I really think that race matters and name the whatever. So you do the test, you're like, oh my God, race didn't matter. Who saw that coming? And whatever it was. Okay, well then from now on, then don't put it in the model. It's not important. Or your gender or whatever it is. Okay, if it's not important, leave it out. Okay, it simplifies my data. It simplifies my collection. It simplifies everything if I can leave a variable out of the model. It makes my life completely easy.
If you found interaction, would you stop there?
If I found interaction, I must leave it in the model. Okay, because that's a big deal. Right? Again, it's that idea that, maybe you take Sudafed for your cold or for your sinuses or something, and then you go in and you get some pill from the doctor, but you don't think to tell the pharmacist to take Sudafed. But all of a sudden, with that, you're dead in a mackerel. Okay? They always talk on TV when they say, well, whenever they announce Viagra, which is one of my favorite stories because, Viagra was discovered when they were trying to find a way to reduce blood pressure, and it's really good at reducing blood pressure. It has a weird side effect. It's very marketable, though. Okay? And so that's what they went with it. But they always say, if you listen to those commercials, they always say, do not take this if you use this for blood pressure. Because that for blood pressure and this, which also reduces blood pressure, can kill you deader than a mackerel. Okay? Deader than a mackerel. So they both have a significant impact, but they also, on blood pressure, but they also work together to really make a big difference in your blood pressure to the point where you could die. Okay? And it's just one of those things. So yes, Viagra has a significant impact on blood pressure. So if it was on the rows, you could have 1 pill or 2 pills or dosage or whatever you want to have it broken out by. Okay? So you could have milligrams of this, milligrams, whatever dosage. And then down this side, you have your different blood pressure medicines, this dosage, this dosage, this dosage. And we dosed up, 20 people in each of those blocks or whatever it is, 5 people in each of those. It doesn't matter. And then when we do it, we test it and we go, well, son of a gun. If you break it out one way, yep, the blood pressure medicine really reduces their blood pressure significantly. And we'd be measuring the blood pressure, of course. And then we do it the other way. Geez, Viagra does it too. Wow, who saw that coming? Oh, wow. And there's an interaction because we killed a bunch of people. Okay? Now, the good news is you probably only killed the people who you're giving a high dosage of both to, probably. The other people were just like, oh, wow, I don't feel good. I'm passing out. But you didn't kill them. Okay? So, small amounts of both of those, but it had a significant drop in blood pressure still. Okay? And that's just kind of how those things work together there. Again, don't ever get rid of any of the factors if there's interaction. In fact, it's quite possible to have a situation where the columns are not important, the rows are not important, but that the interaction is important. Okay? That is quite possible. I can't think of an example off the top of my head right now, but look what the data would look like if that were true. If that were true, then on the columns, I'll just do A, B, C, and then, I don't know, I can't think of the word, blue, green, and that's not green, yellow. I swear I went to college. You wouldn't know it by the way I spell sometimes, but there it is. Now, and you're like, okay, well, that's neat. And then you could go, and then, of course, obviously I'm exaggerating a little bit. Okay, I'm exaggerating a little bit, but notice how the rows will all have the same exact mean, yes? The row and the columns all have exactly the same mean, yes? But it matters where you are. For instance, if you have a C in a yellow versus a B, a 1 and a blue, an A and a blue, that's a big difference, right? So it's an interaction piece that matters here. And so this is overblown because no, it would never actually happen quite like this. But if you did this, what you're going to end up with is there are 3 rows per sample here. What you'll end up with is there's interaction, but interaction only. Oopsie daisy, to the point where I was ridiculous. So allow me to backtrack. Notice what happened right there? Notice what happened right there? There was 0 error. Do you know why there's 0 error? Because everything was exactly perfect. There was no error. There was no variation. Literally no variation. When you look in there, there was no up and down in any of the cells, yes? Right? They were all 1s or they were all 5s. So let me just come back, and I didn't think that through very good. 0.9, 1.1, there we go. 5, 5.1, 5.2. And again, just making up some numbers that are close to where I'll still reject, but giving myself some error. Mm-hmm. 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 Good enough. Now, that should work. I don't want to get too far afield. There we go. That's what I'm talking about. That's what I was going for. Notice how the rows, not significant. Also, columns, not significant. Holy crap, look at the interaction. This is a big deal. You better not get rid of either of them, because together, it's a big deal for us. Okay? So reject H naught, there is no significant difference in the columns, there's no significant difference in the rows. Wow, there is a significant interaction between the two. Okay? It's rare that it's this bad, but it does happen from time to time. Okay? To where there's just the two things, the two factors don't do anything to do by themselves, but together they can be really, really very bad.
If you fail to reject, right?
Yeah, fail to reject, there's no difference in the samples, in the rows. You fail to reject, there's none in the columns. And reject H naught, there is an interaction. Sorry, did I say it backwards?
I think so.
I don't pay attention to myself. Good for you for catching me. Yeah, nice. So anyway, that is 1 and 2-way ANOVAs. I think you'll find them to be pretty straightforward in that there's only so many things that can possibly happen. I mean, frequently, there is a row and there is a column. Think about that for a minute. If you're out planting tomatoes or this or that or whatever it is you're doing, it's not like you're just like pulling random things out of your hat. I wonder if what color hat I wear has any impact on what the tomatoes did. No. You know what has impact on it. Fertilizer, water, sunshine, these sort of things are the things that obviously matter. I'm a psychologist. I care. Touchy-feely crap. Here we go. How the children learn based on whether I'm a nice person or whether I yell at them or not or whatever. And then the amount of time I teach them in class, 20 minutes, 30 minutes, 40 minutes, whatever it is. Oh my gosh, when I'm yelling at them for 40 minutes, they do the best. Or whatever, I don't even know. Yeah, it could go either way, right? There was a deal we studied, it's been 12, 14 years ago now, where we went around to the elementary schools in our district. And because we couldn't figure out why we were getting these weird variations in what the students knew when they got to junior high. Oh, we figured it out. We went around, how much time a day did the kid in your class in elementary school get to do math? Oh, we would do about 20 minutes. 20 minutes, yeah. Well, what are you doing the rest of that? Well, there's art, and there's music, and then there's reading, and then we do some writing stuff, and I'm like, 20 minutes, that's all in math. And then there's like two people that were ridiculously outliers. I spend a good hour a day on math. Really? With second graders? Yes, and I really just do this and that. And this other lady, she's like, and look, and she opened, I swear, I don't know how she got so much crap in her room. But there was literally manipulatives for everything. When I'm teaching this, they move these things around, and I'm like, I'm just lost at this point, going, okay. But yet some people, like a friend of mine, she teaches second grade, first grade? Maybe she's first grade. I don't know, whatever. But I think it's first grade. Anyways, when they come to her class, there are so many different things that she has to do as an elementary teacher that comes into play with what they have to teach, right? So some years she gets kids that are there's so much more ESL some years than the next year, so she's teaching them how to speak English and while she's doing all this stuff, right? So it's, instead of just doing just math, you gotta try to teach them English while they're doing it, oh my word. And then one year they made this huge deal where there was this problem where kids were using too much toilet paper and they was plugging up the toilet stuff. So literally the first grade teachers had to teach kids how much toilet paper to use. And it's just all this other weird stuff that you don't think about, that it's like, it takes away from your time in the classroom, right? And then there's some ladies who, the elementary is mostly ladies, but some of them just have this bitter, and other ones are like, oh, come here, sweetie pie. And so all these different things can play in terms of like how well the teacher understands the curriculum or the math in general, what we're talking about, how they can relate to a little kid, what their attitude is toward the teaching or whatever it happens to be. There's a variety of things. So when you're testing these tests, it's not like you're just pulling random stuff out. I don't think this has any impact, but let's just try it and see for fun. No, you know what you're trying to see, and so you're like, well, this is what we do. So let's see what happens here. So it could be a situation where I wonder if we give people medicine, we could give them like three different types of medicine, or we could give them 3 different levels of dosages. Oh, and by the way, you should take a week off from work and rest or whatever. So if the people actually rest the full amount of time and take this level of medicine versus this level, these people kind of did some rest, but and these people didn't rest at all. And then, oh my gosh, if you rested and took the pills, you did better. Who saw that coming, right? So, the interaction between the two of them, right? So those are the things. That's the nice thing about this stuff. It's not like someone's just making this data up. When you're taking this data, you've collected it for a reason, and you're pretty sure that these 2 things have an impact on the third thing. And what you want to show is that, yes, it's a significant impact, and if it's not as significant as I thought it was, then just don't keep track of it anymore, okay? So, for instance, maybe gender you don't think is a big a deal anymore, so you thought it was a big deal when you tested it, what do you know, it's not important. So get it out of the model. Maybe it's something that's causing a problem in there, okay? So, the project is going to be, well, I'm going to bring it up here so you can look at it. I will be emailing it out with further instructions. However, I want you to start thinking about it. Before you just jump in whole hog and go nuts on it, I would like to have a discussion with you personally about yours. Okay? If in doubt. Why did it underline that? When in doubt? If in doubt.
In doubt, comma.
Oh. There's a reason I teach math. There we go. All right. Nice. So there are several possibilities here. You must not feel obligated to do the ones I suggest. But for instance, for me, it could be about how much baking powder you use and how much your biscuits rise, for instance. Okay, now, not to brag or anything, but I make a mean biscuit, all right? So, but over the years, I've tweaked the recipe to where it's exactly where I want it now, based on how much it rises and what the texture is and stuff. And I found it pretty much dialed in where I want it to, right? And so, but my levels might be 2 teaspoons, 2.5, 3. By the time you get 3 in there, it kind of has a nasty impact on the, I'm measuring rise height, so it may rise a scope. It doesn't really rise any much better after about 2.5. It's kind of, you reached your peak, but then it starts to get funky on the taste at that point, right? The texture is a little weird. So just be aware of that. So you could do something like that. You could do any number of different things. For me, it might be, it might be the height. So I could actually do a test for this. I could make some biscuits. So I can make a half a batch of biscuits, or a batch, whatever you like, and go nuts on it. And I can make it with 2 teaspoons of baking powder and measure the average from that whole pan, right? Boom, great. And then do the same thing for 2.5, same thing for 3, and then you could run through the test on that, do a bonferroni, and then actually work it out. Now, by the way, most people when they cook, they do this all the time, right? Like if you ask your mom, dads, whoever cooks in the house, when you make chocolate chip cookies, what do you go, oh, I said it at 360. Why? I just does better. Well, I just discovered over time. That's right. Because over time, the classic is for a chocolate chip cookie is 350 for 12 minutes. That's classic right there. I mean, every recipe is right in that neighborhood, right? But then some people, you ask them, they're like, no, I said right about here. I use 13 minutes. Okay, all righty then. So obviously time and temperature are important. What are you measuring at that point? Doneness, taste, texture, whatever it is you're measuring. Obviously, those are a little wonky in terms of being able to put a number on it, yes? In terms of crispiness or something, right? Or just the right texture, right consistency, right doneness level. What's tricky to do, obviously for height, it's easier to measure. It's more objective in terms of that. But I want something like that. And then what would you do? So, like your recommendations are, hey, 2.5 is significantly better, blah, 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 whatever. As far as cost goes, I mean, I don't care if you're making 7,000 biscuits a day, an extra teaspoon per batch is not going to kill you cost-wise, so I wouldn't worry about that. I'm only in here for a good biscuit, to be honest with you. That's just an idea. Select an idea that uses a 2-way ANOVA and compare something like the amount of baking powder and the length of time they're baked for and how much they rise. Okay, and see how effective it rise. Was either significant? Was there any interaction? What recommendations would you give me if I were to bake some biscuits? Something like that. It doesn't have to be that exact one, but something like that that you can control. And by the way, control pretty well. Yes. Is that good? You raise your hand?
Yeah.
Anyway, something like that. But it has to be, I want an objective measurement. I don't want to, well, this is the best biscuit right here. I'd like it to be, objective. By the way, in Calc 4, we do a project. I do a project in that class too, and this guy came to me. He's a baker a couple years ago, and he goes, "I want to do this one. Is this okay?" And I'm like, "I guess." And I really wanted to say no, but it intrigued me a little bit. And so what he did was he took different amounts of yeast and different rise times. I think it was. Anyway, whatever. Anyway, he modeled it with, literally he took pictures over time of how much the dough grew, and you could actually see it was how much yeast and how much something else. Anyway, it was nuts. You could totally see, like this pan of yeast rolls up here, they were just kind of and then here, and then they grew, and they got, anyway, there's this one that was like perfect, and then these ones over here were kind of iffy because they got too big and crapped out on it. And it was pretty dadgum amazing, okay? And that's what he actually had done over the years. He goes, well, I knew that one was the best, but how'd you know? He goes, well, that's just how it always was. I went, because you tried and failed over the years. But this is how you do it if you're trying to do a scientific version of the thing. Okay? Again, something that is objective measurement. So I want that. I don't want to hear any like, this one tastes the best or whatever. You could get data from work. So I had a guy last year who was a big guy. Well, he was down in Albany. He's in charge of some of the ambulances down there. And so things like that. So obviously if there's a 1-way ANOVA, is the length of the calls based on time of day. And then with that, bottom line, that would obviously affect how many ambulances or what your staffing would look like. Obviously, there's some parts of the day where you're busier than others, different days of the week. Same thing with cops. Clearly, Friday, Saturday night, you better have all hands on deck. I don't care what size town you are, everybody better be out for the fights at the bars Friday and Saturday nights. And then the rest of the week, like especially Monday, Tuesday, and Sunday night, you can probably just kick back and relax with a very small staff, because obviously there's a significant difference between those. But I want it to be something like from your work, something where you can get some ideas on. I think one guy worked at UPS the last time we did this, and he got some packages. I don't know how many packages come through based on dates and all this and whatever. So if that's something that you have, that'd be great. Work/school, if you have some data from school, that'd be fine too. Same thing with the two-way ANOVA deal. So for instance, for my work, I could get data about referrals or how many, they get in trouble deals, and then you could do it based on, I could break it out by gender and grade, okay? I could break it out by 100 different factors. I could just go in there and mine the data and find out something that I'm interested in, okay? And if I was a vice principal, I might want to know that. I personally don't care right here where I'm at, okay? But if I was a vice principal, I would care, right? I would want to know, are there certain kids that cause me more problems, or I think I'm seeing significantly more freshmen than sophomores or whatever it is, and why is that, okay? And I don't mean just more, I mean significantly more, right? Because month to month, a deal might be, oh, I feel like I really saw the freshmen. Well, you did see a lot more freshmen last month, but on average, there's no real difference between freshmen and sophomores, except that sophomores you expect more out of them, and you don't get more out of them, so it pisses you off more than freshmen. Because freshmen are just overgrown 8th graders, and you don't expect anything out of them. So whatever you get is about okay, I guess, because I haven't missed teaching either of those classes. Taught juniors and seniors for the last 5 or 6 years. It's beautiful. Anyway, I love it. Same thing is true here. If you want to do multiple regression, or you can make up your own. You can you keep going with the biscuit theme. So you can be a variety of things. And what I use here: the amount of milk, the amount of baking powder, and the time. And then, for instance, it could be that time is not significantly different, so you could throw it out of the model. And then when you're done, go ahead and predict for it, right? And then if you made a batch, how close would you actually be? So if you said, I'm going to use 2 teaspoons of powder, a 1/4 cup of milk, and 13 minutes in the oven, and you actually bake a batch like that, how close are you to your predicted amount? Okay, and go ahead and average that batch, right? Because there's always going to be some weirdo in the batch that's going to this one didn't turn out as good as the rest of it. Okay, and then same thing from work. You can get something from work that's similar to number 5 here. Okay, so those are your kind of like your 6 options. Any questions on those at all? If you're in an electronics course and you want to try to incorporate this into something like that, that'd be totally fine somehow. But talk to me first before you just go nuts on it. Because some people go nuts on it and they're like, oh, that's not exactly what we had in mind. So then they get kind of pissed off. And then I'm like, so just ask first before you go nuts on it. Before doing any total bunch of work. Really, this is not a very hard project. If you were doing something like baking the biscuits, you could spend, I suppose, a few hours doing this. I would think you'd actually spend less time doing that than if you were data mining, because if you're data mining, it might take you a while to get the print-offs and get the Excel spreadsheet given to you and screw around with it and whatnot and get it, because it'll never fail. You get it printed out from some database that's in an Excel, but it's not exactly the way you want, so then you spend a couple hours screwing around with that to get down to the data you actually want before you can actually get going on it, which kind of annoys a person after a while, and you're like, ugh. And so just be aware of that. So, I think the whole project start to finish, if you spend more than 4 hours on it, you're probably doing it wrong somewhere. It's just a guess, but anyway, something along those lines. But I would like for next week, if you come with some kind of a plan, so we could have a discussion, just like for about 3 minutes with each person before you leave next week. Because what is this, week 6? Week 5? This is 7?
Yeah.
This is 7 already?
Beginning.
Okay. All right, or you could email me, actually email me this week if you get an idea before next Monday. Email me with an idea, and I can go, yeah, that's good, or So it'd be kind of nice if you could have that going, and it's not necessary, but I'd really like to have it kind of pretty much fleshed out before next week so that, you know, if there's any questions, we can get you pushed in the right direction. Starting next week, well, starting with the video this week, we're moving away from what we call parametric tests. That is, where we're actually talking about averages, or we're talking about standard deviations and things like this. We're going to be moving into what are called non-parametric tests. So we're going to do things based on rankings. Okay, so as you well know, you could finish first in a race by a nose, or you could finish by a mile. You still have first place. Okay, second place could be you just barely came in second, or you got smoked. Okay, but you're still in second place. And the deal is, non-parametric tests are made for that situation where things are not remotely the same. So first and second, second, third and fourth, if they were all equally spaced apart, then it wouldn't matter. But the problem is that frequently you get data that's spread out based on the first one was so much better than all the rest, or the last one was so much worse than all the rest, that it throws everything off, and it's not normally distributed. And so because it violates our normal assumptions, we can't use C's, we can't use T's, we can't use everything we've done. We have to find another way, and that other way is these non-parametric tests. The one that comes to mind, there was a gal, when I used to live in Scappoose, and we was right by the high school, and I come home from work, and during cross-country season, I swear, like 3 times during cross-country season, I get stopped. And like, here comes the boys, and then here comes the slower boys, and here comes the fast girls, and here comes the slower girls, and then, why can't I go? And I'm like asking this guy who's like holding the sign for stopping traffic, and he's like, there's another one coming. I'm like, she's literally 300 yards away. And no, we have to wait for her. I'm like, are you kidding me right now? And we have to wait for her. And she'd come by, and I'm feeling like, if I'm the poor girl, I would not want this huge line of traffic waiting for me, right? But if you're keeping track of, like, she was in 8th place or 12th place or whatever, she was, but she was like minutes behind, not seconds behind, right? So yeah, it would throw off that normal assumption. So this is what we're going to be talking about now from the rest of the chapters on. Is going to be this non-parametric test. So, anyway, that's all I got. So looks like we're a little early, but that's good for me. So have a nice evening. Yes, sir. Oh, let me hit pause before I forget.